Forgot to record. Free electrons. Average velocity of free electrons. Current density. Yeah. Understood this one? Everyone understood drift velocity? Is it or not?
Yes, sir.
Okay. So current density. Current per unit area. It is a vector quantity. Current density is denoted by J I by small s. S is area per cross section. And cos theta. Okay, if I want to find this di, just integrate this one. I equals to integration of J ds. Now relaxation time. It is a time interval between two. Just now we saw here free electrons. I was drawing here like as a, they are randomly moving. So as they are moving, they will collide with each other. Someone. This first one will collide with another one. So that time interval of between two successive collision is called relaxation time. And for small information, drift velocity will be about 10 to the power minus 4 meter per second. So I have one doubt. I have one question for you. If drift velocity is about 10 to the power 1, 2, 3, 4 meter per second, it's very, very small, like negligible speed. Sorry. Okay. This is my question properly. This speed is very, very small, right? Then when I'm switching it on my any bulb, instantly that bulb starts glowing. What is the reason behind that? Can anyone tell me the reason behind this?
Flow of current.
Flow of current, okay. See what I'm comparing here. Velocity is very low here. It's 10 to the power minus 4. But when I'm switching, when I'm just touching the switch and I'm switching it on, instantly that bulb will start glowing. Instant, at a same instant. It won't take like so much time. This means in 1 meter, it takes 10 to the power 4 times. That's what it means. For moving 1 meter, it will take 10 to the power 4 seconds. That's what it means. But still, it is so fast. What is the reason behind that? Come on, someone give explanation. Just line, 1 line, 2 line. What's the reason behind that? Come on, Vishwanath. Think the straight answer. Shruti. No. Sainiyati. What is this? Come on, guys. Ramcharan. It's okay, right, wrong, doesn't matter. Neha, what do you think of it? First of all, you understood the question? Divya?
So is it the current which is set up does not like wait for the flow of electrons?
Wait, I didn't get you last time. What you said? Wait. I didn't hear the last point. What you said?
The current which is set up does not wait for the electrons flow from one end of the another, right? So, like
Acha. See, then think of
so
it.
it is
Yeah. So it is.
it is due to this reason the electric bulb glows immediately when it's switched on.
Okay. Then give definition of current. So what is current now? Flow of charges or flow of electrons. Right. So when current is charges are flowing, that means we are saying current is flowing. Okay.
Yes, sir.
Yes. Somewhat correct, but okay. Let me answer them. See, when we are saying its average velocity, drift velocity is 10 to power minus 4 meter per second square. It is so small, like we can say it's very small. But now, if I give you example as if I'm paying you 0.01 rupees to each people in our country, so we have 1 billion people, more than 1 billion. Okay, if I'm paying 0.01 rupees to each billion, so on account of that, it will be almost big amount, right? For me, I'm paying, for the person who is taking it is just 0.01 rupees, 1 paise. So, but for me, it is like almost 100 million, 10 million. I mean, it's almost 10 million, right? So it matters when we have large number. That means what I'm trying to say here, when we have large number of electrons, so when they are flowing like this, so that is the reason it is getting it on, like it's starting instantly. We have large number of electrons, so small keep adding, it will be one big number. So that this number matters. Number matters. N is N, what we are saying, it matters a lot. Understood, everyone? Guys, are you there with us?
Yes.
What about others? Only Neha and Divya are there. What about others? No? ठीक है. Next. Mobility. What do you mean by mobility? Simple. Movement. So how your movement is denoted by velocity. How much, like we can say, velocity in per unit field. So mobility depends on pressure and temperature. Ohm's law we saw, that is V is proportional to I. Relation in them, that is NEBD. Sigma is conductivity. This all relation you know, right? G is conductance. 1 by R. R is resistance. Sigma is 1 by rho. And rho we wrote above. No, we didn't. Sigma is conductivity. Rho is what? resistivity, right? By relaxation time. These are a few graphs, like, okay, some ohmic graph. In this one we saw, like theta is here, V by I, that is R. Here in this T1 case, theta is more than theta 2. Theta 1 is more than theta 2. That means T1 is more than T2. Q non-ohmic graph. This is this portion. See, this semiconductors, we have a separate chapter, we'll study in detail. This is most important, actually. So resistance depends upon nature, dimension, temperature. So impurities is directly proportional to this one resistance. If impurities increase, resistance of conductor increase. But for semiconductor is reverse. So rho is directly proportional to R, and R is directly proportional to L by and inversely proportional to A. So as I said, if length is, if diameter increased by double 2 times, so here area increased by 4 times, that means resistance decreased by 4 times because they are inversely proportional. So as I wrote above, conductance is 1 G equals to 1 by R, ohm inverse or Simon Moe. These are the units for conductance. As we wrote here, what is it? Where we wrote resistivity or specific resistance. Now, these are most important. Resistivity is a specific property of material, but resistance is the bulk property of material. Read it. Let me give some questions. Okay, what shall I see the questions? Yes. Okay, this is important for next is color coding. Wait, let me just paste it. Okay, color coding. Now see this. Okay. First digit, second digit, multiplier, tolerance, and violin. Okay. This is all about thermistor. Let's discuss about thermistor. Okay. First write this one, thermistor. We'll come back here. Now, if I say thermistor is simply, it's just a heat sensitive device. Okay, and it follows, it doesn't follow Ohm's law, it is non-ohmic graph. It follows non-ohmic. So that means it's specially made up of semiconductors. Okay, which has like ferrous, cobalt, etc. Nickel. That means it has high temperature coefficient. Thermistor is a heat sensitive device. It is made up of semiconductors compounds of oxides, oxides of some nickel, cobalt, etc. Even if you want to add ferrous. So it has high temperature, positive or negative coefficient. Now, what is temperature coefficient if you remember? Let me tell you. Just let me show you a graph. Resistivity and temperature. Even you can Google it. It's will be getting in, even it's there in your book also. Resistivity and temperature graph. So what do you observe here? See carefully. Till then, let me write formula. R for T equals to R naught 1 plus alpha T plus beta T square. Okay. T is more than 300 degrees Celsius. And when it is less than 300, we are just removing beta. R naught 1 plus alpha. Now, what are these alpha and beta? Okay, for T less than 300 degrees Celsius. For okay, what are alpha, beta? They are temperature coefficient. R naught is resistance at 0 degree Celsius. And R T equals to at T temperature, resistance at T temperature. Make a note. So what are manganese and constantan? They are alloy. Do you know composition of manganese? Anyone? Anjali? No idea? Vishwanath?
No idea, sir.
No problem. Vishwanath, do you know composition of manganese? Okay, no problem. Okay. Okay, not necessary you have to remember. But if you know, then you can get idea, okay, what they're trying to say. What is the meaning of this? Let me give you. In this, copper is somewhat 84%. And by name itself, we can say there will be next, it is manganese will be 12%. And nickel is fixed. It is about how many left? 4, right? 4%. And constant, that is name itself, copper will be there, it will be 60%. And nickel fixed, that is remaining 40%. So name some semiconductor. Anyone? 2 standard semiconductors. Come on, guys. This you should know. Standard.
All the elements in between, like the metals and the non-metals.
Yeah, just name 2. I'm asking, just name 2 examples of semiconductor. That is true. All the metals between conductors and non-conductors.
Like silicon, germanium.
Exactly. So silicon and germanium are standard semiconductor. Conductors, you know so many, so let it be. Okay. So from this one, if I want to find out alpha from this equation, alpha equals to R will go there, R minus RT minus R naught divided by R naught T. Now this was R1 value. So if I want to find, there are 2 types of this one resistors. So what I'll do, R1 equals to 1 plus alpha T1. Same manner, R2 equals to 1 plus alpha T2. And this alpha we can find out similar way. It will be R2 minus R1. R1, T2, and all this cross multiply it and find take common alpha outside, and we can find alpha from here also. For less than 300. Okay, so this color band where we wrote above. So to remember this one, almost we have different tricks in your book. So how I used to remember, like BB Roy goes to Bombay via Gateway with gold, silver. I used to remember that way. Whatever way you can remember. Like BB Roy goes to Bombay via Gateway with the gold and silver. Last is no color. You want me to write, or you know this trick to remember? Yes, guys? You want me to write, or you know this trick? So it is increasing, like multiply is like 0, 1, 2, 3, like that. It's increasing like that. If I give one question, okay. So there is a figure shown. Let me draw it. Example number something. Okay, let me show you with example answers. Answer is there already. Fine. It's okay. This is just example, no? Try this question, then I'll show you answer. First try it. Okay, I think so. This was a similar question which we took from an exam question, right? First question. Let me check that. 1 second, guys. It's so much up. Let it do. Okay. See, the question is given here. Suppose the color of resistor as shown in figure are brown, yellow, green, and gold. From left to right. Using the table, find the resistance of resistor. Okay. So as we go from top, see the chart. Let us bring chart down. What was it? Brown, yellow, green, gold. Brown, yellow, green, gold. So green 5, brown 1, 4. Okay. So 1, yes, 1, 4. Green is multiplier 10 to power 5. Number. Okay, first digit, second digit, multiplier, and percentage. So 1, 4, 10 to power 5 plus 5%. Plus or minus 5%. That is tolerance. Multiplier, first digit, second digit, multiplier, tolerance. So 14, 10 to power 5, tolerance 5%. Understood this one? Easy? Guys? Hello people? Knock knock. Are you there? Okay. Chat box. Yes, Anjali? You got it? Anjali, are you with us?
Yes, sir.
Okay. I thought while doing you slept. ठीक है.
So these are kind of hard because we've never learned this. Like,
Okay, this is just a color coding. Simple terms to remember, like if you want me to write, simple, how I used to remember, like BB Roy goes to Bombay via gateway with gold and silver and no color. I used to remember that. This is black. First start with black. First B is black, then brown, then blue. First G is green, second is gray. See here, B Roy, G goes, Bombay, V violet via, gateway gray, way gate gray, way white with gold and silver. And last is no color. First digit, second digit, multiplier, tolerance. This color coding is very simple. Can you remember now?
yes, sir.
Right. In some book, it's like Great Britain and all that. They said, okay. If you want me to share that also, it's there. Let me show you that one, where it is. Oh. Good. I'm not able to paste. What's happened? Can you all see that? I pasted here. Is it visible to all?
Yes, sir.
No, but I can't see. I don't know. Yeah. Here in book it's like a B.B. Roy of Great Britain having very good wife with gold and silver. La la la. Okay, let it be. So whatever you want to remember, just remember. Okay. Can you remember now? Is it easy now? Neha?
Sir.
Is it easy now? Can you remember now?
Yes, sir.
Sainiyati? And Shruti?
Yes, sir.
Okay, great. Okay. I want to go with some question answers, like exam questions, so that as shown in figure. Okay. Okay, just a minute. Let me paste. Post, no paste. Shut off that. Okay, guys. First thing, what you'll do here, make solver series. This is how much is given here. What are values? R1 is 15, R2 is 10, 20, 5, 25, 30, 15. First thing, you'll solve for series, simple. 20, 25, 45 plus 5, 50. So this will be 50 now. 50, 10, you know series formula, right? Equals to R1 plus R2 plus so on. So here, instead of R1, we have R3, R4, R5. So 20 plus 5 plus 25, which is 50 ohm. So if I continue with drawing new circuit, Vishwanath, you can solve, finish it and get me answer. Those who don't know, see here. We are doing it. then what you'll do? These two are parallel. So for parallel, what's the formula? Anjali, do you remember parallel formula? In 10th grade?
1 by R1 plus 1 by R2, 1 by R3, like that.
Yeah. Are you asking or are you answering?
No, sir, I'm answering.
Okay, that's correct. Don't be doubtful. 1 by 10 plus 1 by 50 into 5, which is 6 by 50.
Sir, option C.
Option C. What are they asking, by the way? How much current? What's the current? Right, that's what they're asking. Option C, let me check. No, it is option D. 50 by 6 we got here. R equals to 50 by 6. Solving this one, then these are in series, plus 15 plus 30. It will be if I cancel this, 25 by 3, 3, 15, 45, 90, 90, 45, 25. So 160. 160 by 3 ohm. That is your total resistance. I equals to V by R. V is, how much V? What's the value of V? 15 into 3 divided by 160. Five threes are 32. 9 by 32 amps. So we need in fraction only, right? Yeah, we all have in fraction. So keep it in fraction, 9 by 32. Check here. Where did you where you have done mistake? Check that. Found a mistake? See, getting wrong is not a problem. Then after getting wrong, correct it. Okay, let's go for next question. Okay, it's about potentiometer. And let's try this one first. Options are So if I draw a circuit, okay. So here, formula for net current is E by R. R here it will be resistance plus internal resistance. Same way for power equals to I square R, which is equals to E by R plus R whole square R. So finding maximum power, dP by dr equals to 0. Differentiate this one, we'll get it. So here, E square is common, constant, d by dr, r by r plus r the whole square. UV, U by V form. Differentiation by U by V form. So first term as it is, r plus r whole square. Differentiation of r is 1 minus r as it is. This term will be 2 r plus r. So here r plus r to the power 4, which is equals to 0. So this we will send that side. Equate this, r plus r square equals to 2r r plus r. Cancel all that. Plus r equals to 2r. So r equals to r. Okay, do we have option like this? Do we? Do we have option like this? R plus R? Check. Yeah. B, right? So B is your correct answer. So how I started? E plus R plus R. So R is resistance and small r is internal resistance. So power, to find maximum power, we need to compare, right? Maximum. It's given in question. So dP by dr, it will be maximum power. Then remaining thing is just differentiation. You know, right? Differentiation of U by V. Okay, one question I'm giving as a homework. Try it out. There's a circuit. There's no circuit here. It's there. Try this question as a homework. Okay. Okay, guys. So let's stop sharing. Take this question. Have you taken?
Yes, sir, took us.
Okay, fine.